Let's talk about integer addition. So first of all, the word integer means numbers like this. So 0, 1, 2, 3, 4, 5, forever that way. And 0, -1, -2, -3, -4, forever that way. So it doesn't include fractions or decimal numbers. They're whole numbers that can be positive or negative. So that's what an integer is. So I realize that's kind of a funny name, but let's talk about integer addition. Well, integer addition is pretty easy if they're both negative. So if you have -3 plus -4, that's going to be -7. So if the signs are the same and they're both negative, your result's going to be negative, and you're just adding the 3 and the 4 together. So that's -7. Here's another example here. -2 plus -1 is -3. So that's pretty easy. And of course, you know that a positive plus a positive is going to be a positive, and a negative plus a negative is going to be a negative. This is the one that's a little weird. So let's look at that. So you have 10 plus -2 is going to be +8. I like to think of this as money. If somebody gave you $10, that would be +10. That's $10, your $10 to the good. Somebody gave you $10. And then adding a -2 is like somebody taking $2 away from you. Well, if somebody gave you $10 and then they took 2 away, -2, you would have $8. So that's a +8. If somebody gave you $9 and then they took 3 away, you would have $6. Now, if somebody took $7 from you, you're $7 to the bad. So this is representing someone taking $7 from you. And then let's suppose their conscience was pricked and they gave you 4 back. Well, you're still in the hole $3. So that's a -$3. They still owe you $3. That's what this represents. So -7 plus 4 is -3, because if they took $7 from you but only gave you 4 back, they still need to give you $3. That's a -3, not a +3, but a -3. If somebody took $6 from you and then gave you 2 back, they owe you 4. So -4. So I think that's probably the easiest way to do positives and negatives, but usually in the books, they kind of explain it this way. So if you have one number that's positive and one number that's negative, they say take the absolute value of each one of the numbers. So you put these absolute value bars around them and then subtract the numbers. So the absolute value of 9, by the way, absolute value means the distance the number is from 0. So 9 is 9 spaces away from 0. The absolute value of -5 is +5, because -5 is 5 spaces away from 0. And if you subtract those, you get 4. Now, what you do is you give this number the sign of the bigger number. Which number is bigger, 9 or 5? Well, 9 is bigger, so it's going to be +4. I guess you should think about it up here. 9 is bigger than 5. So since 9 is positive, this is a positive. So that's the way that works. So once you subtract, that's not the final answer. You have to assign the sign of this based on which one's the bigger number. So over here, notice you have -7 and 4. If you take the absolute value of 7, you get 7. You take the absolute value of 4, you get 4. 7 minus 4 is 3. But the answer is not 3, it's -3, because 7 is bigger than 4, and 7 has a negative sign. So that's why this was negative. So that's how you do this with the rules. But I honestly think that thinking of this as money, and positive is somebody giving money to you, and negative is somebody taking money away, actually is a little bit easier way, maybe a whole lot easier way, of thinking about integer addition. So integer addition, remember, these are integers, so that's a fancy name for a relatively simple concept. And if you're adding, this is how that works. These are the rules with signs that are alike, and this is the rule for when the signs are different. And those are some good examples of integer addition problems. See ya.